All right, welcome to another video about Kotlin Coroutines. In this one, I'm going to talk about one of my favorite things, if not maybe even my most favorite thing about Kotlin Coroutines. And before I talk about it, let me paint a picture of a situation that this Kotlin Coroutines feature solves. It's a situation that comes up all the time in Android development. So let's talk about it here. It looks like my volume isn't quite high enough. So let's take a look at this demo application here. This is the one that we're going to be building in this video. It's a very simple app. When I press the Start Job button, a progress bar goes ahead and goes all the way to the end. If I let it go to the end, it says job is complete, so it updates the UI. If I hit Cancel Job, it restarts, and you get a message saying Resetting Job. If I was to start the job and cancel it midway through, I get that message, resetting job, and the job is reset. So this might seem very simple, but let me talk about kind of commonly when you would encounter this sort of situation. So here I am in the Jetpack documentation, or the Jetpack section of the Android documentation. This is where they talk about the kind of recommended architecture for your applications. Specifically, I believe they mention MVVM. So you have your activity, your view model, your repository, and you have your two data sources. You could have many different data sources, but in this example, you have two. You got your room persistence library and your remote data source, which is just basically accessing the internet. You're accessing a REST API, whatever. So what happens very commonly, what happens all the time is you go into your repository, you go to make a request, and say you're making a network request, and for some reason the network is slow. Doesn't matter what the reason is, and you need to cancel that job. So you have a timeout, maybe it's 3 seconds, 4 seconds, whatever you want to wait, and then you got to cancel that job. In the past, this was always very difficult to do. If you were using AsyncTask, this was very, very difficult because AsyncTask is shit. Basically, it's not useful. You should not use that anymore if you are currently using it. You have Executors, which is kind of a little better, but still it requires a lot of code to be able to handle when to execute the timeout, what to do when the timeout happens, how to update the UI afterwards. All that kind of stuff requires a lot of code, and it's a pain, basically. And then coming up, you have RxJava. RxJava, again, makes it a little easier. Actually, it's quite a bit easier because you can just apply operators, say, after this amount of time, do this thing. If there's an error, do this thing. If the timeout occurs, throw an error. There's more options, and it's a lot easier. So now we come to coroutines. Coroutines even take it a step further. They make it even easier, and I have to say I continue to be impressed by coroutines as I'm kind of learning them, as I'm going through them, as I'm getting better and better at Kotlin. And this feature it's really awesome. So I've got a very simple example lined up for you, as I showed you with the starting job cancellation thing. But it's a good one. I really think you'll get a lot of value out of this. So let's, without further ado, let's get into the example. All right, so first I'm going to take you through the code that's existing in this project. You can create a brand new project if you want. I'm starting from basically nothing in this project at all. Activity main is really the only thing that has anything. Just a constraint layout with a linear layout below it, vertical orientation. I got a progress bar, a button, and a text view. So that's all there is in this. Code is going to be in the description of the video if you want to copy and paste it, or you can just kind of watch along and not do the code yourself. But I always recommend using the code. It's always better to kind of follow along than to just watch. So what are we trying to do here? Well, we want a on-click listener on our button. So if I pull up the application, we want an on-click listener on our button, and then when I click it, we either start a job, or if I click it again, we cancel the job and we give kind of a reset message there. So let's start by creating some variables. So I'm going to declare a bunch of constants first of all. Private value, it'll be progress max equals 100. That's going to be the maximum progress allowed for the progress bar. Progress value progress start equals 0. Private val, and then the total job time. So this is going to be the total amount of time that the job takes to complete. It's going to be 4,000 milliseconds. And then I'm going to use a late init variable. I'm going to call this job, and it's going to be a completable job object. So this is a Kotlin coroutine object. It subclasses if we click it here, it extends by job, so it is technically just a job object. The difference with a job object and a completable job object is a job object has kind of more features added to it. And you might have guessed that obviously because it extends job, but let's take a look at some of these other features. You have complete and complete exceptionally. These are kind of the two main things that I'm interested in. Complete will return, well, you can read the description over here. It says, completes this job. The result is true if the job was completed as a result of the invocation of this method and false otherwise. So if I call job.complete, that will complete the job. It will mark the job as complete. And then the other method that I was talking about was complete exceptionally. So completes this job exceptionally with a given exception. So those are the two things that make this job, this completable job object, stand out from regular job objects. And it's really nice because basically what it gives you is it gives you the ability to complete a job on your own terms. So you decide when this job is complete. You don't let the coroutine decide when this job is complete. That's kind of the biggest thing. So if you're doing any kind of a operation, any kind of a request, having the ability to complete the job when you decide or not is a powerful thing. So what's next here? Well, we need to have a way to start this job up. So let's go down. I'm going to create a new function named initJob. And inside of this, I want to first do job button, which is the ID for the button in the layout, the button that starts the job. I'm going to say set text, and this is going to be start job number 1. Or I can just say start job. It doesn't really matter. Start job or start job number 1. Next, I want to update the text view to be blank, even though it will already be blank. But for now, I'll just kind of write, what is the text view? It was job complete text. I'll do set text and just set that to blank. I'm going to create a method for doing that later, but just for now, I'm going to set it manually like this. Now, the next step is going to be actually creating this job. So job equals new job, basically, is what I'm doing there. Because this is a late init, we do need to make sure that we initialize that. So what late init means, for those of you who don't know, it means that this object is not initialized yet. So if I was to go inside of onCreate and do job.complete, it would throw a null pointer exception because that job is not initialized yet. That's why I need to make sure that I initialize it, which is what we're doing inside of the initJob method. So next I want to do job.invoke completion, or invoke on completion. So this is one of the best things. This is one of the best features about this job sort of pattern, I guess you would say. So as I outlined at the beginning of the video, one of the most common things that happens is you wait for a network timeout for a job. If you're making a request, something happens, doesn't matter what it is, you have to either complete or cancel the job, and then you need to update the UI accordingly once that job is complete. So that's what this is going to do. That's what this allows us to do. It's called invoke on completion. So whether the job is canceled or completed, this code will execute. So then inside here, we want to basically update the UI. We want to let the user know what's going on. Was a job canceled? Is it still happening? Was there an error? Whatever. The point is we need to update the user. So I'm going to write it.message. So if there is an error, I want to get the error message. So if, for those of you who aren't familiar with this Kotlin notation, basically it's saying check for null. If it's not null, get the message, and then we can do something. So let's take a look what we're going to do. So we do variable message equals it. It's going to be the string message from that throwable object. And then if the message is null or blank, because it can be null, you can see up here from the description, it can be optionally null. You can see with that question mark means that string can be null. So if it's null or it's blank, then I want to assign a message. So unknown, I'll say unknown cancellation error, because we still need to let the user know. Even if there's not an error message, we still need to tell them that something went wrong and tell them whatever, let them know. So let's do print line, and I want to add in that exception. So first I want to do job. I want to print out the job to the log, the one that is currently being executed. I'll say job was canceled, and then I want to give the reason. So the reason is the message. And then of course that will print to the log, but we need to let the user know. So what we're going to do is we're going to create a method named showToast. So fun showToast. It's going to take text as input. That's going to be a string that cannot be null. And I want to write toast.makeText. And the context of this is going to be this at main activity. Main activity. I'm writing main activity for a reason. So some of you are probably confused why I'm writing main activity. Obviously, this is referring to main activity, but there's a reason for all this. So just hang on. Toast dot length short and then show. So the reason why I'm writing this at main activity is because we don't know if, like, I want this showToast method to be able to be called inside of a coroutine, inside of invoke completion. I want it to be able to be called from wherever I want. So I'm gonna create a new coroutine using the global scope here. That way I can call this method anywhere I want, and I know that the showToast method is going to be called on the main thread. So I'm doing global scope, which is a coroutine scope. I'm writing launch on main. So, and then I'm going to call this inside of here. So no matter what, if this is called inside of a coroutine, inside of my invoke on completion, no matter what, this showToast method will be guaranteed called on the main thread, and that's because that's where the toast is going to be shown. So that's very important. And it's giving me a warning, I believe, because I wrote a capital T there. So this at main activity. So there we go. There's our showToast method. Now I'm going to come up to init job. I'm going to write showToast, and inside here I'm going to write the message. So just passing the message. So that will initialize our job, and also if our job is completed, it will get any error message that's associated with that, and it will update the UI and let the user know, which is often, the most important thing. You always got to let your user know what's going on. Having an error is not the end of the world. It happens, but definitely if you don't tell your user what's going on, you're probably going to piss them off, and they are probably going to uninstall your application. So now the last thing I want to do inside of init job is job progress bar dot max. So I'm setting the max value. That's going to be the progress max, and then job progress bar, the progress will be the progress min. So progress or progress start. So that kind of resets everything. That's going to create a new job, handle the cancellation, or it's going to initialize everything, and then reset the progress bar so that there is a max and there is a current progress value. So next is actually calling this initialization method. So I'm going to do job button and set an on-click listener, It's just going to be a Lambda function. And then inside here, I want to check if it's been initialized. So if job.isInitialized, this is how you check for initialization of a late init value, which is our job object. If you scroll up, you see that it is a late init variable. So I'm checking if it's initialized. I'm not checking if it's null. I'm checking if it's initialized. This is a unique property to late init objects. And so if it is not initialized, I want to initialize the job. And that's going to set up our job, create a new one, all that stuff that we need to do. The next part of this example is going to be handling the starting of the progress, or starting the job basically. So this init job method will create the job. That's all great, but how do we actually start the job and start that progress bar going to the end, and then also handle that cancellation? So the next method that we are going to build is going to be for that. So I'm going to create a new one named fun, and it's going to be an extension function on a progress bar. So I'm going to write progress bar dot start job or cancel, and it's going to take a job as input, which I should have written in there. So coming back up here, it's going to be job, and inside here, as you might have guessed, it's going to be responsible for either starting the job if it has not been started yet, or canceling the job if it is currently in progress. And for those of you who don't know about Kotlin extension functions, all this is I'm saying, here's a method. I'm going to be able to call it on a progress bar. If I call it on a progress bar, I can then access that progress bar by writing this. So see, if I write this, it tells me that I can access that progress bar. And then I can set the progress, I can set the max, I can do whatever. So another really cool feature about Kotlin, if you didn't know that it existed. So how do we check if the job is already started or if we need to start a new one? So I'm going to write if this, which refers to the progress bar, dot progress is greater than 0, then we know that the job has already been started. So I can write print line. I can tell the user, or I can tell the debugger, this job is already started or already active. Let's say already active, because that's technically the status of the job. And I can say canceling, because if it is active, then I want to cancel it. And in case you were wondering, I just used some terminology that you might not be familiar with. So I said is if the job is active or is canceled. So if I do job dot and you can take a look at all these different statuses. So this is active, is completed, is canceled. So what I'm looking for is if the job is active. So that's what I'm saying here. Job is already active. In that case, I want to cancel it. So we can come down here and call reset job, which is a method that I haven't created yet. But that's going to be responsible for actually resetting the job. So I'm going to write Alt or click Alt Enter on there and go to create function reset job. And I'm going to come back to this. I'm not going to fill that out yet. We're going to continue with our start job or cancel, but I will come back to that, and that's going to be responsible for resetting the job so that everything is basically at square one again. Okay, so otherwise, if that job has already been started, I want to do job button and set the text to the job button. So set text cancel job number 1. So that's if we take a look at the demo application, you have start job number 1, cancel job number 1. That's the text that we're setting right here. So after that, we need to fire up our coroutine, because remember, this else statement denotes if our coroutine has not started yet. So we need to start it up. So I'm going to write coroutine context, or sorry, coroutine scope. And here is a very important, this is a very, very important thing that you need to pay attention to about starting jobs, and starting jobs in general, and different scopes for different jobs. So imagine a coroutine scope is a scope. I can pass, I can pass main in here. I can pass IO. I can pass whatever it is, the dispatcher's default, a bunch of different options. Typically, you've probably seen me in my examples pass IO, because that is a background thread. And then I would do, .launch, and I would launch that coroutine, and this stuff would be executed on a background thread, which is a magical thing that coroutines do. But what we are going to do here is we want to tie this coroutine scope into the job. So it's kind of like you create this coroutine scope, and then within that scope, you're adding different jobs to it. So inside here, I can actually do plus job. And what that does is it adds the job to this coroutine scope and creates a brand new coroutine context independent of any other coroutine context. So like, just as an example, if I had another job, say it was job number 2, I could do IO plus job number 2, and that would be a totally independent job. If I called cancel on this job, it would not interfere with this job that's running, and if I called cancel on that job, it would not interfere with the other job that was running. So this is a very important thing, because if I was to, so say I started this coroutine scope, and I wanted to, and then later I canceled it. So like, let's see, I'll just say, I'll do value scope equals this, and then do, if I was to do scope.cancel, if I had any other jobs that were running within the IO, what would you call it? IO context, I guess you would call it. If you had any other jobs that were running in IO, like I said earlier, if I had another job, coroutine scope, and it was running on IO, and I had .launch, and something else was happening in this one. If whoops, this needs to be a capital. So if I called scope.cancel, it would cancel all of the jobs within the IO scope. And that's obviously not a good idea, because you could have literally hundreds of jobs running on the background thread on the IO scope or IO context, whatever you call it. And if you hit cancel, it would cancel them all. So how do you, basically this job sort of pattern is how you get around that. So what you want to do is you want to write IO plus the job. And then if I ever want to cancel just that one job, then I write job.cancel. And that's the magic. So then you don't kind of shut down the entire IO coroutine context. You're only going to shut down that one job that you started up. So that's kind of the focus of this video, showing you how to start one job within a context and then only cancel that job and take action if that job is canceled. Okay, so now in here, I'm going to do print line and let the user know, or let the log know, that this is starting up. So I'll say coroutine this. It's going to refer, you can see that this refers to the coroutine scope. So it's going to have a memory address. So I'm saying this coroutine is activated with this job, and I'll write the job in there. And now we want to start our progress. So for, I'll do I in progress start dot dot and then end at progress max. So I'm looping this integer I from the progress start to the progress max. If we scroll to the top, we see that that goes from 0 to 100. That's all it does. So it'd be 0, 1, 2, 3, all the way up to 100. So then in here, I want to delay this to simulate what a request would be. And I want to do job underscore time divided by progress max. So what that's going to do is it's going to guarantee, and I want to cast this to a long, sorry. And that's going to guarantee that this job is only going to take up to the job time, which is 4,000 milliseconds. So if you want the job to only take 3,000 milliseconds, whatever you want, change that. It's just for demonstration purposes. That's all this is going to do. And then I want to set the progress bar as this goes along. So this dot mention the progress bar. I'm referring to this, the progress bar that this is activated onto, and I want to set that progress. So progress equals I. So now the last thing that we want to do is we want to update the UI and let the user know that this job is complete. So you might be tempted to do, what was it? The text, job complete text, set text, and then just say that the job was complete. So I could say job is complete, but that would create an error because you're trying to access a text view that exists on the main thread from a background thread. Remember, this is still on the IO thread. So we're going to create another method that takes care of this for us. Oh, we still need to build our reset job method too, but let's build this this update text view method first. So I'm going to call it fun. I could do private, I guess private fun update job complete text view. It's going to take text as input, which is going to be a string. And inside here, I want to do kind of the same thing we did with the toast. It's going to be global scope dot launch. I want to launch on the main thread. And inside here, I just want to update the text view. So I'm going to take this, put it here. I'm going to cut this text, do that, and then do update job complete text view and do job is complete. That ensures that no matter what coroutine, what context, where this is called from, it will update that text view on the main thread. And I'm going to do the same thing up here where I updated wherever I did it right here. So it says I'm doing job complete text, setting the text. So update job complete text view and set that to null or empty. And then I can delete that one by pressing Control Y. So now the last thing we need to do is go into reset job and write the code required to completely reset our job. So if it's running, the progress bar needs to get reset, the job needs to be canceled, all that kind of stuff. So let's go in here, and the first thing we want to do is write if the job is active. So if it is currently running or the job is completed. So remember, there's kind of two situations here. If we allow the job to get to completion, the job will be marked as a completed status. So is completed will return true. If the job is currently running, but it's not completed, it will have an active status. So we need to handle both of those scenarios. So if the job is active or if the job is completed, then we want to cancel the job. So I can do job.cancel, and I can pass a cancellation exception. So cancellation exception and pass a message. So I'm just going to say resetting job. And just kind of as an FYI, this cancellation exception will actually get caught inside of our invoke on completion. So that's the throwable that you'll see right here. It will, if we call job.cancel, this cancellation exception will get caught by this invoke on completion. So that's going to be this message that we see. This is going to be the message, resetting job. That's the one that we're going to see print out here. So if you need any kind of, this is not a, I know I'm probably going through this really quickly and you think this is really simple, but this is actually a really powerful thing. You can cancel a job, you can pass an exception, and then you can take action depending on whatever that exception is. And all of this is just so streamlined, so easy to do. Depending on, your different error messages, you might want to show a dialog. If it's a bad network connection, you might want to show a toast message, all kinds of different things. And all of this is very easy to do. writing custom logic depending on the message, and you have even control of what the message is. So really cool stuff, really powerful stuff. So the last thing is, after our job is canceled, I want to initialize the job once again. And the reason why you need to initialize the job again is because once it has been canceled, you can't reuse that job. So if we take a look at the init job method right here, we're actually initializing a new job, and then we're adding an invoke on completion interface here. So if a job is canceled, just remember this: if a job is canceled, you can't reuse that job. You have to create a new one. So that's why I am creating a new job here. So now before we run this, let's just quickly kind of go through this. Oh, actually, I need to also scroll to the top here and call progress bar start or cancel. So job progress bar dot start job or cancel, and I want to pass that job. So for those of you who are unfamiliar with extension functions, this is how you use it. So I'm declaring a method saying start job or cancel. It can only be called on a progress bar. That's why I'm saying progress bar dot start job or cancel, and then passing that job. So anyway, let's quickly run through the logic before I run it, just to kind of review everything. So when the application starts, an on-click listener is set to the button. If this job is not initialized because it's a late init variable, so basically the first time when the activity is started and the button is clicked, we will initialize the job. Let's take a look at init job. If I scroll down init job, the first thing is the start job number 1 message is attached to that button. The text view, the completion text view, is set to blank. The job is initialized, so we create a new job. We add an invoke on completion interface, which handles the event of the job completion or the job cancellation. And then it will show a toast message if there was a cancellation, and let the user know what's going on. So it's a very important thing, being able to take action on the job when it's canceled or completed. Then after you do that, we have just our progress bar being reset. So scrolling back up, let's take a look what's next. So that's initializing the job. Next, we have our start job or cancel. So in here, if the progress bar is greater than 0, so in other words, if the job is already active and doing something, then we want to cancel that job. So job is already active. I want to cancel the job, which is handled by the reset job method. If I scroll down here, reset job just checks for if it's active, if it's completed, and then it will cancel the job and throw that cancellation exception, and then initialize a brand new job. So if it's canceled, this cancellation exception will get caught by our invoke on completion interface. So this is the exception that gets passed here. Then we can take action and let the user know what happened with that job. So the last kind of part of this, if we go back to our start job or cancel method, is the else statement. So if the progress is not started, if there's not currently an active job, if we want to change the text to cancel job number 1 because now the job has started, if they click the button, it will be canceling it. And then we fire up that new coroutine with the job. So this is probably the most important thing about this, this coroutine scope, coroutine context kind of idea. So remember, if I didn't pass this job here and I just had the IO context passed there, and then later on I canceled that coroutine scope, it would cancel all the jobs within that scope. So that is a very bad thing. You don't want to do that. That's the thing that we're trying to avoid. So instead, which is a very easy thing to do, you just pass your job. You do IO plus job. So it creates kind of its own isolated environment just for your job. And it fires up the coroutine and starts it up. Then we have complete control over it, right? Like I said, we can mark it as completed, we can cancel it, we can do whatever. And then when it's completed or when it's canceled, our invoke on completion interface will take care of that, and we can take some action. So that is it. Let's run it and take a look and just make sure that there's no errors before I send you on your way, because I know that would upset you guys. I'm going to click Start Job. There you can see the progress bar starts. I'm going to let this one finish. So letting it get all the way to the end should take 4,000 milliseconds. It says job is complete. Everything looks good. Now I'm going to cancel that job, so reset everything. It says resetting job. There's our invoke on completion interface, canceling that or catching that cancellation. I'm going to do start job number 1 again, and now I'm going to cancel it kind of midway through, and then we get that cancellation message. So we're updating the UI. We're letting the user know what's going on. Everything is working as we expect. So really kind of cool way to manage background jobs, to have a lot of control over them. Like I said, in the past, using RxJava, AsyncTask, Executors, all of these things required so much more code to do this, and it was just a lot harder. Being able to manage a job like this, I think, is a really great thing. And you can have multiple jobs. Like I could have a whole bunch of different jobs inside of this whatever class you were doing this in, and you could do coroutine scope IO plus job 1 plus job 2 plus job 3, whatever. You could create all of these different little environments to have these independent jobs running, and you have complete control over them. So it's a really, really powerful way, I think, to do threading, to do asynchronous work, and have everything kind of work together. And so that's going to be it for this video. The last thing I want to talk about is my newest upcoming course on my website, Powerful Android Apps with Jetpack Architecture, Kotlin, MVVM. We're actually going to be using MVI architecture, navigation components, which is the new way to navigate with fragments, Room, coroutines, obviously, Retrofit 2, Dagger 2, REST API integration, all kinds of really, really great topics, all the newest, latest, and greatest stuff from Jetpack. And of course, this is going to be showcasing some of the best features about coroutines. If any of you are familiar with my other courses, in particular, the one I want to talk about is the local database caching course with the REST API. You know that in this course, we built a network-bound resource class, not network status class. It's a network-bound resource class. This one right here, these couple of videos, that manages kind of our database transactions, our room persistence library transactions, looking at the cache, updating the cache, all that kind of stuff. Inside of that class is where we're going to be adding these jobs and having this cancellation completable functionality. And you'll see it really pay off and show some real great dividends for handling error messages, handling completions, all that network delays, all that kind of stuff. So I definitely encourage you, if you're curious, to check out the caching course, or if you only want to know about the newest Jetpack stuff, hang on and wait for that powerful Android apps with Jetpack architecture course. That is going to be it for this video. If you want to see more coroutines videos, make sure to leave a like and leave a comment and let me know. I'm kind of bouncing back and forth between a bunch of topics right now, so your input is very valuable. I like to do things that most people want to see. So that's it for this video. Thanks for watching, and I'll see you in the next one.